Honors Chemistry. Today we're going to do a conductivity activity where you get to see how different substances are able to conduct electricity in the aqueous state, and if they do conduct electricity, that means there's ions present in the solution. If they do not conduct electricity, they do not have any ions, meaning that they are nonpolar covalent bonds in the substance. And if they kind of, sort of, a little bit conduct electricity, then that indicates that we're dealing with a polar covalent bond. So I have 6 different substances here. We've got sugar or sucrose, and then this next one is sodium chloride. The blue one is copper 2 sulfate. Then we have acetic acid, and we'll be learning all of these names and formulas throughout this unit as we go, but acetic acid is right there, which is already aqueous. Hydrochloric acid, which is also already aqueous, and then the paraffin wax. Okay, so those are our 6 substances we're going to be testing to see if they produce ions or not. That would indicate either they have ionic bonds, if they do produce ions. If they sort of produce some conductivity, then they have polar covalent bonds, and if they don't produce any conductivity, then they have nonpolar covalent bonds. And here is the meter that we're going to be using. It's a conductivity meter. This probe here, we will put that in the solutions. We're going to add water to the solids here and dissolve them, and then we will test their conductivity with the conductivity meter. So let me add water to the ones that are solid. Now they may not completely dissolve 100% because I have a relatively large amount of solids in here, so some of these may only partially dissolve. Try and hit the test tube. Alright, let me add a little bit more. Yeah. Okay. And I can even stir it up, see if I can get a little more of the solid to dissolve. But again, I probably have way more solid than compared to the amount of water I added in. So the sucrose, it did dissolve. It didn't completely dissolve, but yes, I just needed to add, if I added more water, I could get all of the sucrose to dissolve. So yes, that one does dissolve. Likewise, for the salt or sodium chloride, add a lot of salt in there. So it did dissolve, it just didn't all dissolve because there's not very much water. And same thing with the copper 2 sulfate. You can kind of tell the solution itself is blue, so that indicates, even though there's still some solid down in the bottom, that indicates that the copper 2 sulfate did dissolve as well. So the only one that didn't dissolve at all is the wax. Those are completely unchanged. They're floating on the top. So those did not dissolve. Everything else is aqueous. Okay, so now we're going to take our conductivity probes and test each of these solutions and see what their values are. So I'll start with the sucrose. Just going to stick it down in there. I want to make sure that the probe itself gets submerged, and the conductivity on that, really not very much, 97, and that's microsieverts per centimeter. You don't have to worry about the unit on that, but that's what that is. So our baseline is really not zeroing out, but basically there was very little change on for the sucrose. So that, again, what did I say that was? About 97, and we're starting around 60. So that only had about 30. Yeah, let's go with our starting point is about 67. So we really only had about a change of 30. So that means it's just really not conducting at all, as compared to, now here's the sodium chloride. Look at that number. That's a huge number. We're in the 25,000s, and it may not ever settle on an exact number, but the magnitude of the number is the most important thing. So look at that. We're in the 26,000 range for the sodium chloride. So that definitely has some ions in there. Okay, now let's try the copper 2 sulfate. And so now obviously that's not as high as the sodium chloride, but that's still a pretty good, pretty large number. That's in the 3,000s. And again, it may not settle on any one number. Just put somewhere in the, mid 3,000s. We're at about, there we're at 3,100. Okay. All right, now next one is our acetic acid. Let's take a look at that one. Okay, so not kind of in the middle of the road. Again, we're starting off, our baseline is around 70 or so. So this is in the 600s. It's right around the 600s. And I'm washing off my probe in between each one with some distilled water. And now let's try the hydrochloric acid. And boom, big number. This one's even higher than the sodium chloride. We've got in the 32,000s. So huge amount of ions floating around in that solution. 32,000, and so somewhere right around 32,000. Again, you don't have to have an exact number. It's more the magnitude, the place value of the number, as opposed to an exact single digit. Okay, and then finally the paraffin wax. As we said, it didn't really dissolve, but we'll go ahead and test it anyway and see what's going on. Really nothing. Again, starting out around 70, we really have nothing going on there. Okay, so that's virtually, I don't know, maybe 50. So really that did not conduct electricity at all. Okay, so no ions present in that one either. Okay, so using that information, you can determine which of these substances are ionic, have ions in them due to their ionic bonds, versus which ones are covalent. And you don't have to differentiate between polar covalent or non-polar covalent. Just basically, if you decide that it's not ionic, then it's going to be covalent. Okay, so finish up those questions for homework. Bye.